Hey guys, today we got more factoring. Special products. Special products. Let's get going. These are special types of factoring today, and we're going to do three different types. The first one's called difference of squares. I think it's the easiest kind of factoring that you can do. What you need to look for before you do this is three things. First of all, look for a difference. Right? They got to have subtraction symbols. Every one of these has subtraction. That's the only way you can do it. You can't do sum of squares. So once you know it has a minus sign, you need to look at the two terms and make sure they both have square roots or they're perfect squares, like x squared, the square root is x. 36, the square root is 6. So all we're going to do is this. We're going to write x plus 6 and x minus 6. All you have to do, if they're difference of squares. There's a minus sign, both have square roots. And think about it. If I did FOIL right there, if I did first, outer, and inner, and last, those would cancel. I would get x squared minus 36. So that's why it works. Okay, let's look at the second one. Again, there's a minus sign. They both have square roots. You just say y plus 9, y minus 9. If you write y minus 9, y plus 9, that's good too. The third one, there's a minus sign. That's a perfect square. That's a perfect square. The square root of 10n squared is 10n. The square root of 9 is 3. So I'm saying 10n plus 3, 10n minus 3. All there is to these. This is a little tougher down here, but there's a minus sign. Believe it or not, 196 is a perfect square. 49 is a perfect square. And if you're not sure about 196, take your calculator, punch in square root of 196 and see if it comes out even. And it does. The square root of 196 is 14. X plus 7y and 14x minus 7y. That's not completely factored, but we'll get to that on the last slide. So hopefully that makes some sense. Difference of squares, not much thinking there, but you got to look, make sure it has a minus sign and two perfect squares. The next type we're doing is called a perfect square trinomial. A perfect square trinomial. So this is when, and this kind of supersedes slide, divide, slide sometimes. What I want you to do when you start these is look at the first term and the last term and see if they have a square root. And if they do, try it out. Like the square root of y is y, the square root of 25 is 5. So I'm just going to put y plus 5, y plus 5. And check. I'm going to say check the OIL out tomorrow. I'll explain to you what that means. But I'm going to check my outer and my inner, and sure enough, 5 plus 5 is 10. Works great. That's just something to try. The second one, look at the first term, look at the last term. They both have square roots, so try that. Try 3a and 3a and try 4. Notice I haven't put a sign in there yet because this time my middle term is negative. And if I'm going to add two numbers to get a negative number, they're probably going to, and they have to multiply to be positive, they're both going to be minus. So 3a minus 4, 3a minus 4. And one more, these are all positives down here, so this should be a little bit easier. They both have square roots. The square root of 49 is 7a. The square root of 4 is 2. So we'll try 7a plus 2 and 7a plus 2, the same thing. And again, if you check outer, that's 14a. If you check inner, that's 14a. 14a and 14a, 28a. Works perfectly. So two types so far, difference of squares, perfect square trinomials. Got one more type here. And that is this. Always, we should have probably started with this instead of starting with what we did yesterday, but you need to always look for GCF first. GCF is huge, right? Always look for that. For example, this first one right here, I can take out a 5. The 5 is the greatest common factor. And if I take out a 5 out of the first term, it leaves a y squared. If I take out a 5 out of 500, it leaves 100. Now, as soon as you get happy and think you're done, you're really not, because if you look inside here, that's a difference of squares, like from the first slide. They both have square roots. There's a minus sign, so you got to factor some more. Difference of squares, remember we went y plus 10, y minus 10. When we factor those. The second one right here, I need to change colors. The second one, 72 and 32, 8 goes into both of those. So I'm going to take out an 8, and that leaves a 9. And 8 goes into 32 4 times, and the x squared is still there. You know what? That's a difference of squares still left over. So I'm going to go 3 plus 2x and 3 minus 2x. So that's a good review. That problem right there pretty much reviews most of this whole lesson. And the last one of the video. You're probably like, thank goodness. All right, but yesterday when I looked at this, I would have done slide, divide, slide. And you can still do that, but you're going to have to factor out a GCF when you get done, which is kind of a pain. So first thing you do always is look and see if it has a GCF. Look if every term has something in common. And in this problem, they all have a 2. They're all even. So what I'm going to do is I'm going to factor out a 2. I'm going to take a 2 out. Leaves an x squared minus 9x and a 14. All right, now we're back where we were yesterday. So I'm going to see if I can factor what's in here And you can. I'm trying to think of 2 factors of 14 that would give me negative 9. And the first thing that pops in my mind is the right thing, which is 7 and 2. X minus 7, x minus 2. And that's as far as you can go. And that's, so your lesson that you see, your assignment tomorrow is going to have 3 parts. It's going to have a difference of squares section. It's going to have a perfect square trinomial section. And it's going to have a section where you need to find the GCF and then keep on factoring. It's going to say factor completely. But the first step of that's usually going to be take out the GCF. Right? Hope that makes some sense to you. I hope you've seen a lot of this before, and this is review, but even if you have, it's been a couple years, so hopefully, it's coming back to you. I'll see you tomorrow.